Good morning, guys. Today we are going to do something a little bit different. We want to analyze what's going on with the acceleration of an object, or rather, with the motion of an accelerating object from the graphic point of view. So, in order to do that, we will consider the following example. Let's look at the example carefully. Example 1. A given object starts from rest and accelerates at a rate of 5 meters per second squared over an interval of 20 seconds. Draw a velocity time graph for this situation. So what we know about this object is it started from rest, so its initial velocity is 0, and every second that passes, its velocity increases by at a rate of 5 meters per second every second. Now, if we look at this from a graphic point of view, this is what you have. We have a previous presentation prepared for this, and basically, let's first look at the blank space that we're going to use. Your time is in seconds, that's the horizontal axis. Your velocity is in meters per second. And so if you want to go from 0 to 20, perhaps this should be a little bit longer. And you probably can guess that if the acceleration is 5 and the final time is 20, the maximum velocity is going to be 100. So you shouldn't get any closer than that. Now, if you look at the behavior of the time, your time is supposed to start at 0. And at that time, your velocity is supposed to be 0. So this little point over here indicates that the time is 0 and the velocity is 0 at that point. Now, if you let the time run for a while, look at what's going on with the velocity. Perhaps we should look at it a little bit slower. And what you're looking at are points that are indicative of a time and a velocity. So if you start from 0, and then after 2 seconds, it's already going at 10, at 4 seconds at 20, 6 seconds at 30, it doesn't take much to understand that at 20 seconds, we are going to go all the way up to 100 meters per second. Okay? Now, what this really means is that you can actually make a function that describes the increase of your velocity as time passes. And that function is what we call the velocity time graph. That velocity is increasing as time goes by. So we can actually get rid of the annoying points here and make the motion go a little faster in our imaginary time, and this is what you have as your velocity time graph. It starts at 0, and after 20 seconds it reaches up to 100 because an acceleration of 5 meters per second squared times an interval of 20 seconds gives you a final velocity of 100. And so that is the aspect of a velocity time graph for an object with positive acceleration of 5 meters per second squared. So that is it for this video, and I hope to see you soon. Bye.